Page 240 today in your Algebra 2 textbook, we're going to look at solving quadratic equations by factoring. And so factoring is something that you have done before, even in this class, all right? And so we're going to kind of look at how to help that solve a quadratic for us. And so you've learned how to solve quadratics by graphing. Factoring is another tool for your quadratic tool belt, all right? And so one thing that the book reminds you of is that we're kind of dealing with FOIL here. So what factoring is it's kind of like the opposite of FOIL. All right, FOIL was taking two factors and putting a quadratic or putting a problem together. And then factoring is kind of undoing a problem, all right, that was put together by FOIL. All right, so they work hand in hand. They just go opposite directions. All right, so we're going to jump to an example one. I'm going to show you real quick how to write a quadratic equation when they give you the roots. So if you know, or if it said, you know, that we have roots at -1/3 and 6, then this is how we do it. There's a little formula in your book right here on page 240 in example 1. I'm just going to go ahead and show you how to do it. So it's going to be x minus and then whatever your root is. So we have 1 at -1/3 and we have 1 at 6. All right, so we're going to set those factors equal to 0. So the factors are the opposite of the root. So what that cleans up to is x plus 1/3, all right, and x minus 6. So take the opposite of the root. That's where this plus sign and this minus sign comes from, all right? If you get a fraction, move that number in front of the x. You've already seen some stuff with this when you learned factoring way back, just as a quick review at the beginning of this class, but we're going to hit it again. So I'm going to rewrite this factor as 3x plus 1, and then I'm going to do times x minus 6. Again, these are just equal to 0 because that's where we said the zeros were, or the factors were. All right, now we FOIL. All right, I'll write it out here just as a reminder. When we're putting it together, we FOIL. First terms are 3x times x is 3x squared. Outer terms, 3x times -6 is -18x. Inner terms, 1 times x is positive x or positive 1x. Last terms, positive 1 times -6 is -6, all right, equals 0. These are your like terms right here in the middle. Add those together. -18 plus 1 is -17, so we have 3x squared minus 17x minus 6 equals 0. So that's going from the roots to the quadratic. Real simple to do if they give you the roots or the x-intercepts, okay? All right, just want to show you that before we get going. All right, let's jump into factoring. All right, so factoring is going to work several different ways, and we're just going to do some examples. I'm example 2, all right, on page 241. So it says this. It says solve, and it says 16x squared plus 8x equals 0, and we're going to be solving this by factoring. All right, so when this happens, the first step of factoring is always find a GCF and pull it out if you can. Well, when I look at 16x squared and 8x, my GCF is 8x, and I'm going to pull it out. Since it's two terms, it's going to look like the distributive property. All right, so remember, 8x times something is 16x squared. Well, that 8 times 2 is 16, and x times x is x squared. So 8x times 2x is 16x squared, and then 8x times what is 8x? Obviously, positive 1. Something times 1 gets itself. We need that 8x to be there. So this is kind of cleaned up, or this is factored out. So we GCF, and then we try to factor it. Well, we can't factor it because we're already good. There's no more quadratic left here. So now the third step is solve, and here's how you solve. You split up your factors and you set them equal to 0. So you're going to write 8x equals 0 and 2x plus 1 equals 0. Remember, we're just finding the spot or the two spots or maybe no spots where this quadratic graph crosses the x-axis. This is how you do it using factoring. So 8x equals 0, well, I divide by 8, and I get x equals 0 as one of my roots. We do it over here, so the first thing I do is minus 1, so I get 2x equals -1, divided by 2, x equals -1/2. There are my two roots, 0 and -1/2. So make sure you're catching on what happens factoring, pulling out a GCF right there, okay? Pretty simple to do. You may have to pull out a GCF and solve. If you get to looking like at guided practice 2C, look, there's an A5 and an A4. You may have to pull out more than just one variable, all right? Pull out the number that both numbers, the biggest number that they share, and then pull out the biggest amount of letters that you can. All right, let's keep going down. Example 3, we're going to roll. I got this. x squared plus 16x plus 64 equals 0. All right, so we got a trick that we can do factoring if we have a couple of plus signs or if this sign is positive. It doesn't matter if this one is or not. And you have a perfect square right there. If this is a perfect square, then something that we can try to do when we factor this, now remember, we're going to factor before we solve. First of all, we're going to check for GCF. We don't have one. There's a 1 in front of the x squared. There's no x with the 64. So I got a plus sign. That's a perfect square. I'm going to try to take the square root of x squared, which is x. I'm going to try to take the square root of my last number, which is 8. And then I'm going to look at this sign. Whatever it is going in between. This is called, all right, factoring when you have perfect squares. We can FOIL this real quick and get x squared plus 8x plus 8x is plus 16x, and then 8 times 8 is 64. That works. So if this is a perfect square, we're going to see if we can make it match that middle term, which it does. Another thing you can do, and I'll show you this in the calculator in a minute, I'm not necessarily going to on this one, okay, is you can go to y equals do 64 divided by x and go look at in the table and go look at what adds up to 16. Now you're going to see 1, all right, and 64, and you're going to keep going down, and somewhere you're going to get to where x is 8 and y is 8, and 8 plus 8 is 16. Again, I'll show you that in the calculator in a second. Now, once you've done that, we set these factors equal to 0 because we are solving, all right? So example 3 told us that we were solving. So we're not just factoring anymore. Now we're solving. All right, you can see that I get the same answer. Here I get x equals -8, and here I get x equals -8. If you're paying attention when we were graphing, this means the vertex is on the x-axis, and we only need one of these answers. The answer is x equals -8. It's a double root, okay? Vertex was on the x-axis, all right? Pretty simple to do. We're looking at factoring, and then we're looking at solving. Let's keep going. Example 3b. Part B, all right, is this. X squared equals 64. Now you learned in the last section that you have to get it in standard form for a quadratic anyway. So I need to move the 64 over. So that's obviously minus 64. So x squared minus 64 equals 0. Now that looks different because there's no linear term. That's okay. We can still factor this because when there's two terms, if there is a minus sign, we might be able to do the perfect squares thing. So the first thing we do is GCF. There's not one. There's no number that goes into both terms. There's no letter that goes into both terms. There is a number that goes into both terms. It's 1, so that doesn't really help us, all right? And so now I'm going to try to do this. I'm going to take the square root of x squared again, which is x and x. I'm going to take the square root of 64, which is 8 and 8. But since this sign was minus, one's going to be minus, one's going to be plus. If you FOIL that, you'll get back to where your middle term or your linear term cancels out. And we'll end up where we are. Again, we've already talked about factoring. This is something that came in chapter 0. So you're going to have to review how to factor if you're not getting that. You're going to have to look at it. All right. Now we set our factors equal to 0 because we're solving. X minus 8 equals 0. X plus 8 equals 0. Again, our directions were to solve this. Well, here I add 8. I get x equals 8. Over here I subtract 8. And I get x equals -8. Those are the two x-intercepts, or the roots. Those are our answers right there. 8 and -8. All right, some good stuff going on. A lot of stuff right here in chapter 4, section 3. All right, let's roll. Let's keep going. So I'm going to show you two just good reviews on factoring. I'm going to try to wrap it up. All right, this is something that you're going to have to do. So I'll show you some calculator stuff that can help us here. So now we're at example 4. All right, and we're part A. Now these are just regular old 3-term quadratics. We got to get them in standard form. They're going to be, to start with, we got to factor, and then we're going to solve. Whenever it says equals 0, that means solve, or if there's an equal sign in there, we're trying to find, since it's quadratic, the two x's that make this equal to 0. Are there always going to be 2? No, because there could be 1, it could be a double root, or there could be 0. All right, remember we learned when we were graphing that there may not be any x-intercepts, but we'll deal with that when we get there. All right, so here's what I got to do. I've got to break this thing up, and here's what I want. Here's kind of the steps. I need factors of C, all right? So factors of C from up here that like having steps, all right? And I need them to add or subtract to get B. C is the constant, B is the linear term. I need to look at factors of C that add or subtract to get B based on whatever the sign is. All right, so for us, here's what we're going to do. We're going to go to the calculator. I'm going to look at 20 divided by x. We're going to look at factors of 20. All right, so I go to y equals. All right, I do 20. Clear what's in there, 20 divided by x, and I go to my table, so second graph. All right, so here's the xy table. Here's what we start dealing with. I get 1 and 20. Does that add to get 9? No. 2 and 10. Does that add to get 9? No. Now at 3, there's a decimal. Don't worry about it. Those aren't factors. 4 and 5. Does that add to get 9? Absolutely. That's the factors. Now if you look, we get 5 and 4. Does that matter? No, because 4 times 5 is the same as 5 times 4. When the numbers start repeating, you've checked them all, but we already found our answer. Here's the two factors I need, and I'm going to go in here and write x plus 4 and x plus 5. And again, that equals 0. If you FOIL this, you get back to the quadratic. So make sure that your signs match up. 4 times 5 is 20, and 5x plus 4x is positive 9x. We've got to be good there. Now, we set the factors equal to 0 and solve. So our last step here now is to solve. That's what's different. X plus 4 equals 0. X plus 5 equals 0. If I can go fast, we minus 4. I get x equals negative 4. Here we minus 5. I get x equals negative 5. There's your two x-intercepts for this problem. Negative 4, negative 5. All right? Everybody okay with that? All right, let's check example 4b. A little bit tricky one right here, but we're going to walk back through. So here's example 4b. 6y squared minus 23y plus 20 equals 0. All right? Don't worry that it's a y. If you like leaving it as an x, that's fine. Again, example 4b. That's a b, not a 6. All right, so as we go check this, let's check for GCF. Is there a number or a greatest common factor that goes into 6, negative 23, and 20? My guess is no. They're not all even. 3 doesn't go into 23, so I think we're good. There's not a y in every term, so I can't do this. All right, in terms of GCFing, there isn't one. All right, so here's the steps here. My first step, when a is greater than 1, that's bigger than 1 right there. The number in front of our quadratic is greater than 1. I'm going to go multiply a times c, and I'm going to rewrite this problem. So here's what I got. I'm going to do 6 times 20, and I'm going to rewrite this as y squared minus 23y plus 120 equals 0. I want to get it to where a is 1. Now, if a is ever negative, just flip all your signs, okay? And then if a is not 1, then we're going to do these steps, all right? So this is a good review on factoring when a is greater than 1. All right, so I now need to follow these steps. So the steps are up here, or what's coming in now, right here, okay? I need to do factors of c that add or subtract to get b. So here we go, y equals 120 divided by x. We're going to do it in the calculator. Where did I get 120? Multiplying a times c. Again, that was 6 times 20, gave me that. So calculator, y equals 120 divided by x. Go to your table. We're trying to find negative 23. Now, if you go down here, when I add them up, they're all going to be positive, right? So, sorry, so you can see it. 1 and 1, that's positive. 2 and 6, 3 and 40, 4 and 30. Those are all positive answers. I need negative 23. So what side of the table do we need to go on? Here we go. Negative 1 and negative 120 is negative 121. Let's keep going. Negative 4 and negative 30 is negative 34. Negative 5 and negative 24 is negative 29. Negative 6 and negative 20 is negative 26. Man, we're not there yet. There we go. Negative 8 and negative 15. When I add those, I get negative 23. So in my XY table, I just like writing out the ones that I want. Negative 8, negative 15. Okay? Check it in the calculator. TI calculator will help you. All right, write them out. So I've got y minus 8. All right, then I've got y minus 15. Obviously equals 0. Now, here's the next step, though. All right, that was different than factors of c that I had to get b. All right, we have another step. Now we put this in. Divide by our original a. Whatever a was, again, up here, that was 6. Okay, I'm going to bring that in and divide. So I'm going to divide by 6. I'm going to divide by 6. So when you divide by a, the first thing you need to do, if you can, is you need to reduce the fractions. Well, I can. So that's going to become y minus, all right, 2 goes into both of these, so that's 4/3. All right, let's look at this. 3 goes into both of these, so that's y minus 5/2. All right, equals 0. So again, a little bit tricky right here, but we reduce the fraction if we can. That reduced to 4/3. If you're not good at that, just put 8/6 in the calculator, math enter, enter. 15/6 in the calculator, math enter, enter, okay? There's a minus on there, so they're going to stay minus. All right, now, all right, I'm just going to write here denominators. You need to get rid of the denominators if they're not 1. What does that mean? That means take that 3, put it in front of the y. Take that 2, put it in front of the y. So rewrite your factors right here. So this is going to be 3y minus 4 times 2y minus 5. And again, the equal 0 is telling us that we're solving. If you FOIL this right here, you get back to 6y squared minus 23y plus 20, which is where we started. But we're solving this. We're finding the roots or the zeros or the x-intercepts. So here's how we do it now. 3y minus 4 equals 0. 2y minus 5 equals 0. Set your factors equal to 0 and solve. So right here we're going to be plus 4. So I get 3y equals 0 plus 4 is 4. Divide by 3. I get y equals 4 thirds. 1 1/3. That's fine. Come over here. Plus 5 to both sides. 2y equals 5. Divide by 2. Y equals 5 halves. There are your two x-intercepts. 4 thirds and 5 halves. So there's your answer. Do they always have to be positive? No. Do they always have to be negative? No. Do they always have to be whole numbers? No. I mean, there's kind of this thing that keeps it fluid and keeps it working. All right? We're finding x-intercepts. This way, though, we call them roots, and we find those from our factors, or we call them zeros, and it's where we set our factors equal to 0 and solve. A lot of stuff here. Good review on factoring. If you're not good at it, you'll be getting a lot of practice. All right? Thank you for paying attention. Come ask for help if you need help.